Good morning, everyone. Thank you for joining today's session. Um, Today, we will continue with the software carpentry curriculum, looking at the next topic, which is programming with Python. I will post the link with the material we will be covering today in the chat. Um, ah, yes. Thank you, Julian. Yeah, see, you posted the link now. Uh, So as before, what we will try to do is introduce the basic concepts of Python programming and try to apply them to a specific example. In this case, we will try to um, mimic the analysis or a very common situation in research that comes to analyzing some input data to try to gain some insight out of it. In specific, we will be looking at data on inflammation, patient inflammation data, which have been giving some arthritis treatment. So this data consists of a series of text files with data arranged in rows and columns. Each row, um, actually, I should probably give you first, share my screen first. Let me just go ahead and do that. Now, there you go. There you go. So hopefully you are seeing my screen. So this is the website with the training material. If you scroll up to the setup tab, there are some instructions that hopefully you have seen and about the requirements for today's lesson. So we need Python. So because we're going to be learning how to program in Python, there are a few ways to install it. The recommended way and the way I'm going to be using for today's lesson is through Anaconda, and I will be using Jupyter Notebooks. But you can also install it directly in your terminal and use it through your terminal. Again, there are some instructions in here. So, and most importantly, there are a couple of zip files that you should download into your desktop and extract them. So these are the files that contain the data that we will be using for today's course. So the instructions ask you to create a directory in your desktop called swc/python and place the zip files in the directory and extract them. That will give you access to the input data. So please let me know if you had any trouble with those set of instructions. We'll try to help you. So let me go back to the description of the data. So as I was saying, the different input files that we're going to be looking at describe the reports of arthritis from different patients. So the text file will contain rows that correspond to patients and columns that correspond to the reported level of arthritis for different days. And we will try to analyze this data, printing maximum levels of arthritis reported by each patient, or the average number of the average arthritis per day, etc. Print some figures to try to gain more understanding and try to do some more statistical analysis. Right, so that's more or less the objective of the course. The course is fairly long. There's material to cover about 7 hours and a half. Today's course is 3 hours, so we will try to, not including the break, so we will try to cover as much as possible to give you the basics. So let me make a start with the fundamentals. So we'll jump to the first section, and let me now share my screen. I will jump to my Jupyter Notebook. So I can now share. So hopefully you are now seeing my Jupyter Notebook website. So this is how it looks on the first. Right, that's a good point. Thank you. Yeah, we're about to ask that. So let me see if we can do that. Let me resize this and see. Does that look better? Excellent, thank you. So this is how more or less looks like when you open it. If you can see here, I am on a specific directory in my desktop and my swc python / python dash python. So you can navigate through your through your documents to point to the place you save the input data. I can open a new notebook using Python 3 by going into this drop-down menu. It's called New using Python 3. If you're using Python to your terminal, obviously you don't need to do this. You can just type Python in the terminal and it will open an interactive interpreter. Please let us know if you have any trouble. So this will open and my Jupyter Notebook. So we will start with the very basics, show you more or less what are the capabilities of what you can do with Python. So for starters, it's probably good to highlight that you can use Python as a general purpose calculator, meaning that you can do all the basic mathematical operations that you're used to. For example, add numbers, you can do this. And the Jupyter Notebook, the way that you enter data is by clicking on the cells, typing the operation that you want to do, or the function that you want to execute, and then hit Shift Enter. That will ask the interpreter to execute whatever you enter in the cell and give you the result. You can modify the content of a previous cell by just clicking on it again, and for example, typing something else, and do Shift Enter again, and that will update the content, the result. So, and automatically will create a new empty cell for you to keep working if you have other content to enter if you want. Right. So okay, so you can do the basic mathematical operations. Now, obviously that's good, but it's more useful if you can actually manipulate data that you have. So to do that, it's the most common way is to assign values to variables. So the way to do that in Python is, for example, through using the equal symbol. So this equal symbol. So this will assign the value of 60 to the variable weight underscore kilograms. And there are just a few remarks in here. Every language has its own rules on how variables are defined. Um, so in Python, you can use most characters, but there are a few rules, a few characters, and a few ways in which you cannot define variables. For example, you cannot start a variable with a number. Uh, that will give you an error. It's good to try to point out how Python will try to report the errors. It will do its best to try to tell you what type of error it is and where to look at for the cause. So in that case, they will try to say it's a syntax error because maybe there is something not clear in the way we entered the command, and it will try to point us to where the Python believes the error is located. So it's worth taking a look at the error message and try to read it. This one is fairly simple. It's only 4 lines, which is good. So this, once we have a value assigned to a variable, we can recall that value by typing its name. And I will quickly introduce you to something new. Probably let me go back there a bit before I introduce you to functions. So at this point, I have assigned the value of 60 to weight in kilograms. If I were to do this, this is a different variable since Python differentiates the is case sensitive. So this for Python, these two variables are different. There are programming languages where they are case sensitive, so it wouldn't matter if I start my variable with a W capital letter at the beginning or not. It will be the same variable. For Python, they are different. So something to have in mind. Also, by default, if you're used to other programming languages like Fortran or C, C++, etc., you might be used to specifying the type of data. By default, Python assigned that the type on its own, so it tries to recognize what type of value you are assigning to a variable, and it will set that by its own. So if you want to see what the type of data a variable has, I'll show you in a moment, but just for now, let me show you. So at the moment, I'm assigning in integer values. So if I were to type another type of data, for example, a float, meaning a value with decimal points, I will do it in this way. So in this moment, I have changed the value of this variable. It doesn't hold. It doesn't have 60 anymore. It has 60.3. I can assign other types of data, like for example, strings. Now page ID will have this string of 001. Pay attention to the way I entered that string. I was using this single quotation marks. You can, now that we have a few variables, we can use them to do some operations. Like for example, I could use my weight in kilograms to perform some calculation. Like for example, if I want the weight in pounds, I could do something like this. A nice feature of Jupyter Notebooks is that you can press the tab key, and it will try to autocomplete based on variables or functions that are already defined. So if I were to press the tab key at this moment, it will try to tell me what variables are already present, including that one, the one that I'm just trying to define. So I can just select the one I want and multiply it by 2.2. So this will recall the value I assigned to weight in kilograms and multiply it by 2.2 and assign the result to weight in um, uh, there's a question in the chat. Does the automatic data type assignment cause limitations in precision handling? For example, is there a way to differentiate between 8-bit numbers and 16-bit numbers as important? Yes, there is. And we will try to see it more once we start working with NumPy, since it's probably mostly more useful in NumPy arrays. But yes, there is a way uh, to specify the precision, what type of integer or what type of float value you're using. And yes, it can cause issues. It has performance implications, etc. For now, I don't think we're going to be seeing much of that since it's an introductory course. But yes, if you explore this implementation, you can find methods to specify those aspects. Right. So in here, just assigning a new value to a new variable. So I can modify my variables and other methods. Like for example, I get to modify my strings as well. So for example, if I want to redefine the string that I just defined, I can do something like inflammation, and then so this is way to, so it might be new to some of you to try to add to a strings what will come out of that. So the way that Python handles string adding is concatenation. So when we are using the add symbol, some symbol in strings, what Python understands is that you want to join them. So so I think that this is a good point to introduce some of Python built-in functions. So the most useful one, the one that we're going to be using a lot today, is the print function. So functions are some are written like this, and in Jupyter Notebook you will see a change in color with whatever you type, something that Python believes is a name. So in this case, print matches a built-in function. Built-in functions in general have this kind of syntax. So you will specify the name of the function and then some parentheses or brackets where you may need to enter some arguments if you expect this function to do something with them. In this case, this function in particular requires some values within these parentheses because what we want is to print the value. So you will need the value to be printed. So for example, I can use my patient ID, and if I do shift enter, I will print the current value, and you will see that what I did before in this cell, I provided this string and I added it, I joined it to the previous value I had defined for patient ID, and now it is joined. And I can do the same with the other values I have defined. So hopefully that's starting to give you an idea how you can define variables and how you can see that there are concepts of functions and how you can use them. I mentioned something about the types. So as I said that Python defines those automatically. You can try to get to ask Python what is the type of a variable by using another function. So that function is called type. I will use it within my print function just to print the message, to print the output from the type function. And I can do, for example, wait, and that will tell me that this variable is it's a float type. And as expected, if I were to do the same with patient ID, it will tell me that it's a string. So that's another way to let you know how you can find out the type of variables, but also pay attention to how I'm kind of nesting the use of functions. So within my print function, within their parentheses, I'm using another function. So the way this works is that I can ask a function to be executed within another function, and the value that is my inner function, in this case type, returns will be used by the external function print to do something. So hopefully that's clear. We will be doing some more examples about that kind of usage of functions later on. So hopefully that's not too complex. Just another remark is that some of you might be used to, I don't know, working, for example, with spreadsheets, where if you define we did in here, as we did with weight in pounds equals weight in kilograms times 2.2. And if I were to print, by the way, you can use more than one line in the cells. And if I, for example, I use 2 lines, it will run the first one and then it will run the second one. So in this case, and it will print only the result that where specifically you want it to print something. But now, if I were to redefine kilograms to something else, you see now that I have redefined weight in kilograms, but my weight in pounds is the same, and despite the fact that weight in kilograms, I use weight in pounds was calculated using weight in kilograms. So there is no concept of remembering the dependencies, as in, for example, spreadsheet. Just in case that's you're used to working with that kind of workflow. Right. So I will try to now advance to the next section. There are some exercises in the training material to try to check your understanding of how variable assignation and variable operation works. Please feel free to take a look at those. I'm a bit concerned about the time that we have available for this course, so we'll try to move on and just stop for exercises that I think is worth doing together. So these are the basics. So now what so this is all good. We can use Python to do some basic calculations. We can assign values to variables. We can manipulate those variables. and we can print something to the screen. Now, the next bit is trying to show you how to do bit more complex operations. So for that, Python has what's called libraries, and those libraries, a collection of different functions grouped by, I would say, topic, perhaps, um, that allows you to do many more complex, complex operations. So one of the most common ones, the more useful ones, I would say, is NumPy. So that one stands for numerical Python, and what it has is lots of functions to manipulate datasets, to define datasets and manipulate them in ways that try to facilitate their analysis. So the way to have access to those different libraries, those different functions, is by importing them into your current environment. So to do that, we use this keyword, which is import, and then to NumPy. And this may take a second to load all the different functions that are available within NumPy. And from this point on, you have access to a new set of functions, and on top of what you already had before. So to try to display them, there are a couple of ways. You can take a look at the documentation, which is always the recommended way to explore new functions and libraries for which you are not used to. But you can also do NumPy, for example, use the name of the library, in this case NumPy, and then add a dot. And if I hit the tab key, it will display a menu, at least in Jupyter Notebooks. And I think in the Python interpreter, in the terminal, it might display a list of functions as well in directly the terminal. So you can see that it's pretty long. So this will show you all the different functions that are available. I don't know all of them, as you might expect. But say, for example, I have one function that I want to show you, which is load txt. If I didn't know what this function does, I could type my help function, help, and Python will try to tell you retrieve any information, any help information it has for that particular function. Hopefully, the message, the help message will make sense. So one thing I want to show you is that the functions have this kind of format, and it has different arguments that it can take. Many of those arguments are set to default values, which you don't need to change unless you know that's necessary. Most of the time, the default values are set to some sensible value. So you only need to provide those that are mandatory, like for example, fname, that in this case stands for file name. So let me now make use of this function to try to load a text file. So as before, numpy dot load txt, and I open the parentheses, and I need to provide the arguments I need. So fname, and now I need the file name that I want to access, or I want to load. So for this, I need to provide the location of the file name, and so that's in relation to where I'm currently am at the moment. So let me go back to my first tab to show you I am in this directory at the moment. So my data is in this directory. So I need to provide it with reference to my current location. So data, and if I hit my tab key, it will open a set of possible completions I can use. So I will use the first one, and now we'll provide a second argument, and for that I need to use this symbol. And for this particular file, because I know how it looks like, I know that the way that the different fields are separated is using the symbol again. So this is a specific format for this type. So comma separated values. That's the CSV stands for. So I know that it's separated by commas. So that's why I'm using this delimiter. If you check the help message, you will see that the delimiter is set to none by default. So no symbol is used. But I know this. I need to change that. So if I hit Shift Enter, it will go ahead. This function will go and try to load whatever was contained into this in this file and print it directly here. So we can see more or less the content of what it currently has. So the way this looks is so. NumPy tries to save space by default, so it won't show you for big files. By default, it won't show you everything that is contained in it. Meaning that if the output doesn't fit into the string, by default it will use these dots to indicate that there are several values in between. So it is just showing you the first columns and the last columns in this case. Also in the rows direction, it will use the symbol in here to indicate that there are many missing hidden rows in that location. So it will just show you the first three and the last three by default. Another way that NumPy is trying to save space is that, for example, if the numbers have if the decimal places are occupied by zeros, it won't show you those zeros. It will just show you a dot. So 0.0 is probably what we have in our file, but it will just show you 0 dot. Same for the rest. Right. So up to this point, that's fine. We have loaded this value, but if you notice, we're not actually assigning this array into anything. So it's, by default, my function is just dumping the content into the string, which is not very useful. So I might probably want to save it to some variable in order to do something meaningful with it. So I will save it into this variable called data. Name data information delimiter, and I click enter. Now it's nothing is printed. That's because it was saved into this variable. If I wanted to see what type of data my data variable contains, I can do it as before. So you can see now that my data variable is a NumPy and the array, meaning it is a n-dimensional array. It is a two-dimensional, but it could potentially have more dimensions. So there's that's one way. NumPy arrays have what is called additional information attached to it that you can explore. as we did with the functions, data, you can add a dot to explore what kind of methods or functions within are provided by NumPy arrays. So if you were to press the key tab, you can see there are different types of elements, different types of methods or functions you can access that are specific for NumPy arrays. For example, you can search for dtype, and this will retrieve the type of data and that data holds. And there's a difference in here. So what I did here, when I use the type function on my data variable, it retrieved the type of the what type of data, what type data is, what type of the variable data is. So it's a NumPy n-dimensional array. However, it doesn't tell me what is specifically what is the type of data that it contains. So what is inside of this NumPy array is given by this other function. So dtype, and that will tell me that my data variable contains floats in the 64-bit precision. So by default, you can see now that there are some defaults being used by NumPy when importing data. You can change that if you specify different arguments to the functions that we have used. Right. So hopefully it's not mixing things too much. Please let me know if something is not clear at this point, because we're going to be trying to make it a bit more building on top of these concepts. Yes, I think the way to do that. I don't know if you can do it within the current notebook that you are, similar to how you would do it in R, for example, to set the working directory. But you could do it from here if you were to go into data and start your notebook from that location. You wouldn't need to specify data anymore here. You will be inside the data directory. That's one way to do it. I suppose there are other way to do it. Right. So now we have the data inside. Let me show you another useful function provided by NumPy arrays. So if again I open different options that I have, I can look for example, shape function, and I can type this one. If you notice, I'm not using brackets for this kind of functions because they are provided by the NumPy array. So this is just like functions or methods to extract certain information that comes attached, or metadata that comes attached with NumPy arrays. So this one in particular would tell me the shape it has, meaning and for this case, I mean how many rows and how many columns. If it were a two-dimensional array, you will have more elements. If it were a one-dimensional array, we'll only have one, etc. So that's all good. We have the data now saved in our data variable. We will probably want to use it in some way. So the first thing to do probably is to try to extract some data or access some data, some elements out of it. So do this. So the print function, so far we have been using it only with one argument, but print function can accept multiple arguments, and all of them will be printed. And the benefit from that is that you can say, for example, you want to print some constant string, and maybe after that you want to print something else, maybe a variable or something else. So in this case, it will print the first argument, so the string, followed by the second argument, in this case, a particular element from my data array. So the way we access elements in a NumPy array is in this way, using square brackets, and we need to provide the location of the element that we are interested in. Yes, that's a good question. Yes, so it is rows and columns. So the first element in here is the row number, and the second one is the column number. And here comes something else that might be confusing for people coming from different programming backgrounds, is that Python starts counting at 0, which is different from other programming languages, like I believe Fortran, MATLAB, and R. I think they start counting at 1 because that's the kind of sensible way to do it. But Python starts counting at 0, similar to other programming languages like C and C++, which if you're used to start counting at 1, it can be confusing. You might take a bit of time to get used to it, but hopefully it shouldn't be too difficult. You can access other values. Like example 3020, and it will give you the value that you have stored in at that location. So another bit that you might find confusing if you are used to working with Cartesian coordinates is that Python starts counting at the top left of your array, similar to how you will be working with matrices. If you're used to that, then that's fine. That's natural. I will do it in that way as well. But if you were expecting, like for example, if you're working with Cartesian coordinates, you were expecting that the first element to be in the bottom left, then you might find it a bit odd. Just something that I wanted to add. So Python starts counting at 0, and it starts from the top left. All right, so now we can access single elements. That is good, but maybe we want to access more than one element at one time. We can do that. By slicing our data. So slicing is just accessing specific ranges in our dataset, in our array. In the same way, we use the same notation. Just that in this case, we're going to change a bit. We're going to use for the rows. Say I want to access the first 4 rows. Will be this way. So that indicates the rows, and I want to specify the columns. So maybe I want the first 10 columns, and I do this. It will return this value. Notice that I'm using up to 4 here and up to 10 here. So the way this works in Python, the notation is that the last number that you indicate is not contained. So meaning for the rows, this is row 0, this is row 1, this is row 2, and this is row 3. So there's no row 4, because 0 to 4, if you were to include 4, would be 5, well, 5 rows, right? So again, it can take a bit of time to get used to that. So that's how it works. In the same way in columns, so you have column 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the 10 is not included. So you will be printing 0 up to 1 minus the name, 10 minus minus 1. No. So hopefully that's clear. Another way to do this, since by default Python, if you can select different ranges. You don't need to start at the first one. You can do this, like for example, like if you want to type, if you want to print the columns 5 to 9. So the next 5, the next 5 rows. Sorry, you can do it like this. You don't need to specify if the first element is in your slice is the first element in the array, in the first column, for example. You don't need to specify it. You can just drop it, and Python will understand that by default you will be using the first one, and it will give you exactly the same output. Similarly, say for example that I want, again I can do this. And I can change, for example, from 36. And if I don't include the next the limit of my slice in the columns field, it will understand that I want to my range should run up to the last column. So let me do this, and in this case I'm printing from 0, because I'm not specifying, but the default is 0, to 2. So row 0, 1, and 2. And for the columns, I will be running from 36, 37, 38, and 39. That is the last column. Hopefully that's that's clear. Please let me know if I going too fast or too slow, or if I'm making you be missed, and I will try to clarify. Right, so now we have a data stored in a variable. We know how to access some of the elements. Now it would be good to try to get some more insight about the dataset, the data contained in our dataset. So there are some predefined methods in NumPy arrays. So for example, NumPy, you can access some functions. For example, if there's one with the so this function, this NumPy function, will take one argument. That's the argument. That's the array that you want to calculate the mean value. So it will take whatever values you provide. So in this case, the whole dataset, and it will go ahead and calculate the mean value for all the elements contained in that dataset. Something worth mentioning is that not all functions require an argument like we have been doing so far for the print function, or for type function, or for this function, for the main function. We always provide the parentheses and some value between them. Not all functions require that. For example, the functions, one of the functions provided by the time library you see here, this one is, I'm not adding any argument here, and it's returning a value. So that's because this function doesn't necessarily need any argument to work. So it really depends on the function that you're using. Most functions will need something to work on, but not all of them. But even if they don't need something to work, some input argument, they will still require the braces, the parentheses. So something to have in mind. Another thing about Python grammar, it's something I found a bit confusing at the beginning, because I wasn't used to it, is that you can assign multiple values at the same time, which is handy. At least for me, was took a bit of time to get used to that, especially when reading Python code. Like for example, if I want to assign the maximum values, the minimum values, at the standard and the standard deviation in one go, in one single line, I can do it like this, and just need to specify the corresponding functions that will provide those values. So, as you see here before, we had a mean function. We have equivalent functions to calculate the maximum value in the array. The minimum value can have another. You have another one with the same, with a similar functionality, and also NumPy has one that provides a standard deviation. So, and you see, if I provided three variables here to be defined, I need to provide some three values as well. So, and that's fine. And now I can do something with them, like example maximum inflammation. Yes. So yeah, so in this case, the assignment is from leftmost, rightmost. What if the number of variables on the left is different than the number of values on the right of the assignment operator? It will probably get an error. So I think that's what you mean. And it will throw an error. And again, Python will try to tell you, it will do its best to point you to the right direction, try to find the cause of the error. And it says not enough values to unpack. Expected 4, but got only 3. So that's the question. They was expecting 4 because I added this one, dummy one, but they I was only providing 3. And so now max val, and I can bring the value for the max value that I got. Let me just copy this and save a bit of time and just amend it a bit. Minimum. Main value in here. Standard deviation. Sorry for the typos. If I'm doing any introducing any typos. And if I hit this enter, I will get the value that I got from my previous line, multiple assignment. So hopefully that makes sense. So right. Something else that it's worth mentioning is how to introduce comments. if I were to, trying to add some meaningful comment documentation to my code to try to remember what a specific line of code was doing. I can do that with the symbol, with the hash symbol. Hash symbol, yes. So comment, and for example, if I were to extract, say let's add something more meaningful. Access data for the first patient. I can do it like this. So what I'm doing here is specifying I want the row 0. That's the first row, and this because I'm not adding in the columns. I'm adding the slice, the range I'm specifying doesn't have a start value or an end value. By default, it will be from the beginning to the end. So this is the way to specify that you want every single value in the columns. So, and I can now print it the same, and it will return that that row. So these are the inflammation values for my first patient, and you can see here this wasn't processed by Python, so it was ignored. But for me, it could be useful to have a note in there to try to remember what it was doing. If I wasn't used to this notation, I could add some note on that saying that that's the way to access every single value in the columns. So another useful thing is that I could, for example, if I wanted to add, for example, the maximum value, if I want to access the maximum value of my patient, I could do something like this again. Numpy max, and I can provide the array that I have. It only expects an array. We were using a two-dimensional array before, but this array is one-dimensional, which you see here, and it doesn't matter. The max function from NumPy, which expects an array, doesn't really care if it is a one or two-dimensional. It will return the maximum value. Something interesting is that you don't actually need to create this variable. If the maximum value from the first patient is what you actually wanted to begin with, you don't need to create an intermediary variable to do that. You could do it directly. For example, I could have done data 0, and if I hit enter in here, it will return the same output. So what this is doing is this bit in here is running first, and is returning one-dimensional array, which is the same. It will return exactly the same as what we had in here, and that in turn will be used as an argument for the max function, and that will be used by print to print it. So hopefully that that is useful. So in that way we can avoid that using intermediary variables if what we wanted and it was just the maximum value for our first patient. Okay, so we have seen several functionality for using NumPy arrays. What if we needed the maximum inflammation for each patient for all days, or the average for each day? So So we need to do the same operation, but for all patients, or for all days. And there's a nice figure in the training material. Let me just share that. Try to simplify what I'm doing, what I'm saying. There you go. So so far, say that we want to calculate the maximum information for each patient. That means we will need to analyze the data in this direction. Hopefully you can see my mouse. It's a bit smallish and I can barely see it myself. But I'm trying to highlight the image they have on the left, the one that has the rows going in horizontal direction. So you will need to, for each patient, you will need to explore every single entry, every single column to try to extract the maximum value, and you will need to do that. Say that you need to do that for all patients. The other alternative, for example, is that for example, you need the average value for every day. To do that, you will need to add up the patient information for day 0, and then for day 1, for day 2, to calculate the respective average. And we will do that by going through different axes in our array. And that's the key, that you will be working with different axes. And there is a way to do that. So let me go back to my notebook. There you go. Right. So the way this works is that remember I told you about the help function. Say numpy .max, and it will tell you the different. Well, it will print a help message, hopefully a useful one, but it will also tell you some of the input arguments that it can take. And I was expecting to see an axis value. Yes, there it is. Sorry, an axis value that you can specify, and that means that you can specify over which axis you want to do the calculation. So let me simplify this with print numpy.max and say data. And now I will specify for my max function, I will specify the second argument, which is the axis one. And I will need to decide over which direction I want to calculate the maximum value. So I want to go through the days for each patient. So the rows are the first axis, so that's axis 0, and the columns are the days, so that's axis 1. Remember, the Python start counting from 1, and the axis is rows and columns. So axis 1 refers to the columns, and I want to do analysis over the columns. So I want to be looking the maximum value over those columns. So this is the way to do it, and this will bring the maximum value for each patient. And you can confirm that this actually kind of makes sense if you do something like this, like numpy, let me just do it in the same line. Just to exemplify one additional thing. If you notice, this will return an array, right? So this array, so this is the same as this, and that's a numpy array. And a numpy array, you can access functions from that belong to the numpy array. So you can actually do this. And will tell me they have 60 entries. So hopefully that makes sense. So what I'm doing is my max function is returning a vector, and from that vector I can access its shape function this way, and I can confirm that indeed it has 60 entries that are the 60 patients. So that gives me confidence that this output actually is the maximum value, the maximum arthritis value for each patient. So now let me try to calculate the mean value for every day. Data axis, and in this case I want to go through the days. I want to calculate the average value, the mean value for all patients in different days. So I need to go through the calculation over axis 0, and that will give me this output that is also a vector. So I can check the shape it has. It has 14, so that makes sense because I have 40 days. I have more or less confidence that this corresponds to the average value for each day. Hopefully that makes sense. Please let me know. It can be confusing working with a different axis. It takes a bit of time to get used to it. I know it did to me. But once you start understanding what it does and working with it, it kind of makes sense. There are some exercises in the training material that could be useful to go through to see if you can predict what the different commands will do. It asks you to work with the slices, modify them. Yeah. So right. So somebody has asked me to try to explain again what the different axis 0 and axis 1 means. So let me just present the analyzing data. There we go. Let me just stop sharing first. So, there you go. So the problem was we can calculate the maximum values and average values and minimum values for the whole data set or for specific rows or columns. So the problem was what do we want to do this for? What say I want to calculate the maximum value for every single row, or the average value for every single column in one go. And yes, and NumPy, the NumPy arrays allows you to do that within the function itself has that functionality. The way to do that is that you need to provide it with information that you want to do the calculation over a specific axis. So for the maximum value, for example, if you want the maximum value for the patients, we will need to do the calculation. If you see in the left image, we will need to search for the data in the horizontal direction, and that is axis 1, because remember the rows is axis 0 and columns is axis 1. So to calculate the maximum value for each patient, the calculation needs to be done over the horizontal axis, as in the left figure shows, and that's why we need to specify axis 1 in that particular case, in the left case. On the other hand, if you wanted to calculate the average for each day, as in the right figure, you will need to do the calculation following the vertical direction, because you will need to add the entries for different patients corresponding to the same day, and then divide it by number of patients to calculate the average. So you will need to do this over axis 0, following that direction, the vertical direction. Yeah, that's as I mentioned, can take a bit of time to get used to how this works. But can be once you get used to it, it's very powerful, since it allows you to do multiple calculations in one go. Hopefully, I don't know. I basically repeat myself, so I'm not sure that make it clear or not. Let me go ahead. So, as I mentioned, that there is some different exercises in here that probably it's worth, if you take a look at them. We have a few minutes before the break, so it could be worth leaving it to you now to those exercises, and then we can probably give you those few minutes, maybe 5 minutes, to go through them and try to take a look at the solution right before the break. What about that? 5 minutes to go through these exercises? I think that's enough. Yeah, let's do that. Let's try to do that. Let's take 5 minutes, and if there is more doubts, we can probably spend a minute, take a look after break. So, and leave it to it for 5 minutes, and then I'll try to go through the solution with you. Right. Let me just go with you through the first exercise, slicing the strings, just before the break. So this is a slightly different one, since the strings are not necessarily something that we would expect to be able to slice, as we did with our arrays. So the exercise, what it's asking us is to define a string and try to come up with exemplify how we can create a slice out of it. Let me just Let me copy this and print the last 3 characters. And this just is an example that yes, we can actually treat arrays in a similar way that we did with treat the strings in a similar way that we did with excuse me, to arrays in the sense that we can slice them. And then the exercise goes to ask us how we can retrieve some values out of it, and ask us what is the value, the element for this. So this will be 0 to 4. As we expect, this oxic including G. And then 4 to, so that is the from element 4 to the end. And then what will happen if we do this? And as we saw before, that indicates that we have the whole array. It indicates as asking us what happened when we use negative indices. What would this mean? And what this means is actually the negative index. What it does is it starts counting from the last element, so it would print last character n. So if we use -2, it will print e because it's the second to the last, and if I were to do this, you can see it will print from a character 1, that is x, to the second to the last character, that's e. So hopefully that's kind of the bit the new bit that this exercise wants you to notice. You can use negative indices. So right, I think we're 1 minute into the break, so we'll leave it for here for now, and then continue with the rest of the solutions after the break. So thank you. See you at 11:30.